Usually when we talk about investigating a crime scene, there is a highly rigorous, almost sacred protocol that investigators are taught to follow right from day one.
Oh, absolutely. I mean, that protocol is really the foundation of forensic science. You secure the perimeter, you make sure no one touches anything, and you meticulously document what is physically present. You don't guess, you just observe.
Right. And the logic there is super sound.
Yeah.
You photograph the shattered glass on the floor, you measure the exact distance of the baseball sitting in the corner of the room, and you let that physical evidence dictate the narrative of what happened. You basically run from the evidence directly to the conclusion. It's binary, it's clean, and fundamentally it's comforting because it relies on objective reality.
Yeah, that is the ideal standard for any investigation, whether it's a burglary or a scientific inquiry. The evidence dictates the narrative, regardless of what the investigator expected to find when they walk through the door.
But, okay, imagine walking into that room. You see the shattered window, you see the baseball on the floor. But before you can even pull out your camera, the lead detective turns to you and says, okay, listen up. We know for an absolute fact that a bird flew in, died of a heart attack, and then a highly localized, incredibly rare micro-earthquake shook the building just enough to drop this baseball from a shelf on the ceiling. Now, your job is to figure out how the shattered glass proves that exact story.
Wow. Yeah, at that point, the entire scientific method has been completely inverted. You've predetermined the conclusion.
Exactly.
And because you've locked yourself into that highly specific, inflexible narrative, you are forced to, well, to contort all the physical evidence to fit a story that just doesn't naturally make sense. You stop looking for the truth and you start looking for validation.
Which is wild. So, welcome to another deep dive. Today, our mission is to take a massive, uncomfortable magnifying glass to the foundational paradigm of modern geology and paleontology. We are looking at a concept called uniformitarianism. For well over a century, the standard scientific consensus has required that all geological and biological history be explained exclusively through the lens of deep time. This is a framework that restricts scientists to slow, gradual prophecy think, millions upon millions of years of patient dust accumulation or slow river erosion, and it strictly forbids catastrophism.
It's totally encapsulated by the famous geological phrase, the present is the key to the past.
Right. I remember that from high school earth science.
Yeah, exactly. The assumption is that if a river cuts a millimeter of rock per year today, then a canyon a kilometer deep must have taken 1,000,000 years to form. It requires a uniform rate of change, and it demands that the Earth's past environment operated under the exact same physical and chemical constraints that we observe today.
And to explore how this constraint actually affects our understanding of the planet, we are diving into an incredibly extensive, highly detailed, and honestly, completely paradigm-shifting document. It's titled Earth, A Biography of Chaos, The Unified Theory of Geologic History, and it's written by Darrell Waters.
But before we go any further, we really need to establish some ground rules directly with you, the listener.
Oh, definitely.
The source material we are unpacking today directly challenges the established scientific consensus. Furthermore, it presents a historical and geological framework that very closely parallels the biblical narrative of a global great flood.
Yeah, the elephant in the room.
Exactly. We want to make it explicitly clear that as your guides on this deep dive, we are not taking sides, we are not endorsing this text, we are not advocating for a specific timeline, nor are we trying to settle a religious or scientific debate.
Right, our job is just to be an impartial mirror to the source material.
Precisely. We are here to unpack the author's fascinating arguments impartially. We're going to help you understand the mechanics of how this text critiques the constraints of uniformitarianism and what physical evidence the author claims has been systemically misinterpreted to basically protect the status quo.
Because this text forces us to ask a deeply uncomfortable question. What if the standard explanations for the Earth's biggest anomalies, from the impossible biomechanics of giant dinosaurs to the bizarre physical asymmetry of the moon, are actually just a series of invented special conditions?
Yeah, what if these highly localized exceptions were designed solely to protect an unquestionable deep time narrative?
Okay, let's unpack this.
The most logical place to start is with the author himself, Darrell Waters, because his background fundamentally shapes the lens through which this entire text is written.
Right.
He is a complete outsider to credentialed academia.
He's a truck driver, actually.
Huh?
But the text provides a crucial bit of context about his cognitive profile. It notes he has an IQ of 150, and he was reading at a college freshman level while still in elementary school.
Which is incredible.
Yeah, But he ultimately felt alienated by the traditional, rigid educational system. So instead of a university laboratory, he spent 30 years observing the American landscape from the cab of an 18-wheeler.
And that outsider perspective is vital to the text's core thesis. Waters argues that because he is not an academic, he doesn't have to worry about departmental consensus.
He doesn't have a boss telling him what to research.
Exactly. He isn't beholden to securing grant funding from institutions that demand adherence to the standard model, and he faces zero publish or perish pressures. He had the freedom to simply look at the physical landscape scrolling by at highway speeds, cross-reference it with geological textbooks, and ask questions that standard geology just seemed unable to answer cleanly.
He essentially spent 3 decades applying that crime scene analogy we opened with. And the philosophical critique he presents in the opening chapters is devastatingly simple. Science is supposed to run from observation to hypothesis to conclusion.
Right.
But under the uniformitarian model, he argues that the institution of geology starts with the conclusion, deep time and gradual processes, and adjusts the evidence to fit.
That is the absolute crux of his argument. When a physical anomaly arises in the field that contradicts the slow and steady model, the standard framework does not rethink the foundational model. Instead, it invents a localized exception.
A special rule just for that one weird rock.
Exactly. It proposes a rare, unrepeatable cosmic event, or it simply adds uninterrogated eons of time to make the math work out. Waters argues that a pattern of localized exceptions is not a scientific explanation, it is an evasion tactic.
I mean, I understand the philosophical critique, but I think it's important to push back on the premise a little bit. Isn't it completely normal for science to have exceptions? Nature is messy. It doesn't operate in a sterile vacuum. Couldn't these geological anomalies just be localized quirks of a chaotic planet?
Well, that is the standard defense of the consensus. Local anomalies happen, but Waters counters by pointing to the sheer scale and global consistency of these anomalies.
It reminds me of finding a perfectly fresh sandwich sitting on a park bench.
Okay, I like where this is going.
Right, so if I find one, my immediate assumption is that someone just left it there 5 minutes ago. But if I'm operating under a strict paradigm that says no human has been in this park for 10 years, I'm forced into a corner. I have to invent a wildly complex theory about how local microclimates, specific humidity levels, and highly unusual chemical preservatives somehow kept this specific sandwich fresh for a decade.
Yeah, that requires a lot of mental gymnastics.
Exactly. At a certain point, the math gets so complicated that the simplest answer is just to admit somebody was in the park 5 minutes ago.
That analogy perfectly captures what Waters calls the knife-edge layer boundaries. This is one of the first physical anomalies he started cataloging from his truck.
If you drive through the American West, or really any mountainous region where they have blasted away the hillside to make a highway, you are looking at a road cut.
Basically a man-made cliff right next to the road.
Yeah, and a road cut is essentially a cross-section of geological time. And what you often see in these road cuts are 2 distinct geological formations meeting perfectly. Above the line is one kind of sedimentary stone, let's say a bright red sandstone, and immediately below it is a completely different formation, maybe a dark shale.
And the critical observation is the boundary line between them. Waters points out that this line is often incredibly sharp. He notes you could literally run a fingernail along the transition point.
Which seems normal until you apply the standard uniformitarian timeline to that exact spot. Under the standard model, that boundary supposedly represents thousands or sometimes millions of years of time passing between the deposition of the lower layer and the arrival of the upper layer.
Let's follow that logic through to its physical conclusion. If 1,000,000 years pass between layer A and layer B, that means layer A was the exposed surface of the Earth for an eon.
And surfaces experience weather.
Right.
It should have been rained on, subjected to wind erosion, baked by the sun, frozen, and thawed.
It goes well beyond just weather, too. There should be evidence of what geologists call bioturbation.
Bioturbation.
Yeah, it's the accumulated chaotic disturbance of the topsoil by living organisms. It's the churning up of the dirt by earthworms, the deep penetration of plant root systems, the burrowing of insects and mammals, and the chemical breakdown caused by microbial life.
Okay, so a lot of activity.
Exactly. If a surface sits exposed for 1,000,000 years, it becomes a heavily scarred, mixed, and degraded transition zone.
But the boundaries Waters is pointing to in the geological record show absolutely none of this. They are, as he states, knife-edge clean.
They look like two freshly printed pages of a book pressed together. Waters argues that this physical reality exists because nothing happened between them. There was no exposure, there was no weather, and there was no life churning up the soil. The transition from depositing the bottom layer to depositing the top layer happened so fast that the surface between them never had the time to become a habitable surface at all.
So how does standard geology explain a perfectly clean boundary that supposedly sat outside for a million years?
The standard model typically explains this by invoking specialized local conditions. They might argue that it was an exceptionally calm, sterile environment, or that a subsequent erosion event perfectly and evenly shaved off the entire bioturbated top layer right before the new sediment arrived.
A perfect continental scale shave that leaves no blade marks. That feels like a stretch.
That's the author's contention, exactly. When you see this perfect shave systematically, globally, across every single continent in hundreds of different geological strata, it ceases to be a localized exception. The author interprets this as evidence of a hydraulic sorting sequence.
Like water sorting dirt by weight.
Right. It's the physical signature of a single, massive, rapid depositional event where different densities of sediment settled out of turbulent water in rapid succession.
So if the rock layers themselves lack the physical scars of deep time, that naturally leads us to question the things buried inside those layers. And that transitions us to one of the most visually striking arguments in the text, the polystrate paradox.
Ah, yes. A polystrate fossil is an organism, most frequently a massive tree trunk that has been preserved vertically. It is found standing straight up, cutting through multiple distinct geological strata.
I want to make sure I have the visual right. We're talking about a fossilized tree standing up like a pillar, and the rock layers are stacked around it like a multi-layered cake.
That is exactly it.
And under the standard model, those different strata are supposed to represent millions of years of patient accumulation. We're talking about a millimeter of dust or silt settling every single year.
The biological paradox is immediate and severe. A dead tree standing upright would completely rot away, reducing to unrecognizable organic mush within a century or two under virtually any normal surface conditions.
Obviously, wood rots.
Right. Wood is consumed by fungi, bacteria, and insects. It absolutely would not stand there perfectly intact for tens of thousands or millions of years, waiting for the rock layers to slowly build up around it.
So to maintain the deep time model, how does the consensus handle a tree that crosses a million years of rock? Do they dispute the dating of the rock?
No, they cannot dispute the rock dating without undermining the entire geological column. So they invoke a local rapid burial event.
There's that special localized condition again.
Precisely. The explanation is that in this specific spot, a highly localized mudslide or sudden river flood buried this specific tree quickly, preserving it before it could rot.
I have to admit, that sounds totally plausible. I mean, local rapid burial happens all the time today. A river bursts its banks during a hurricane, a hillside gives way, and a tree gets buried in 20 feet of mud in an afternoon. Why isn't that a sufficient explanation?
Local rapid burial is an observable reality today, but Waters points out the insurmountable scale of the problem. We are not talking about one anomalous tree in one isolated prehistoric mudslide.
Oh.
There are thousands upon thousands of polystrate fossils. There are entire vast forests of upright tree trunks preserved together.
The text highlights the Joggins Formation in Nova Scotia as a prime example of this, doesn't it?
Yes. The Joggins Formation features multiple levels of polystrate trees, penetrating through layers of rock that standard geology claims took millions of years to form. And these formations are not unique to Canada. They are documented on every single continent.
Which means the standard model is forced to invent thousands of perfectly timed, localized rapid burial exceptions, occurring over and over again all over the planet, simply to protect the assumption that the microscopic layers of sediment around the trees took millions of years to accumulate.
Waters argues we are looking at this backwards. The tree is not an anomaly to be explained away by local magic. The tree is a physical clock.
A clock?
Yeah, it is a biological timer telling you exactly how fast those sediment layers formed. Because we know the maximum time a tree can stand before rotting, the layers it penetrates had to be deposited fast enough to seal the organism before decomposition set in. According to the text, every polystrate fossil is direct physical evidence of rapid, catastrophic sediment deposition.
Here is where it gets really interesting. Because the UTGH doesn't just stop at individual trees or even localized fossil forests, it scales this argument of rapid burial up to entire continental ecosystems. This brings us to the formation of coal seams and petroleum deposits.
Right, so under the framework of uniformitarianism, coal is formed when dead plant matter slowly accumulates in a localized, stagnant swamp environment. This peat builds up over millions of years, eventually gets buried by geological shifts, and is compressed into coal.
But the text points out a massive geographical problem with that model.
Yeah.
There are individual continuous coal seams in the United States that can be traced seamlessly from Pennsylvania all the way to Illinois.
That is a massive distance.
It's the exact same layer, maintaining a consistent composition and immense thickness over hundreds of miles.
And local swamps, by definition, are bounded by local topography. They sit in basins or valleys. They do not span continuously across hundreds of kilometers of a continent, ignoring elevation changes.
That makes zero sense.
To generate a coal seam of that sheer mass and geographic spread, the standard model requires an impossibly uniform, continent-spanning swamp that existed completely statically without any major climate shifts or drainage changes for eons.
Okay, so if the standard swamp theory fails on a spatial scale, what does the unified theory of geologic history propose as the mechanism?
It proposes that fossil fuel deposits are the compressed, hydraulically sorted remains of an incredibly dense, highly productive pre-flood biosphere.
Wait, like a single event?
Exactly. According to this model, it wasn't a swamp that sat there for a million years. It was an entire continental forest ecosystem that was violently uprooted, swept away by a massive planet-wide hydraulic event, sorted by the physics of water flow, which naturally separates vegetation into massive mats, and buried simultaneously under kilometers of heavy sediment.
Wow.
The sheer weight of that rapid overburden compressed the organic matter into coal almost immediately.
It's the difference between raking leaves in your yard every autumn for 10 years versus a Category 5 hurricane blowing every single tree in your town into one massive pile in a single afternoon. The physical evidence looks like the aftermath of a hurricane, but the standard model forces scientists to argue for the 10 years of patient raking.
And that profound contradiction in the physical environment leads directly to an even more startling contradiction in the biological record.
Oh, this is my favorite part.
Because it's not just the plants and the sediment layers that conflict with the current environment. It is the animals themselves. The creatures that supposedly lived millions of years ago possess anatomies that literally break the laws of physics if we assume the Earth's atmosphere hasn't changed.
This is where the text completely shifted my perspective. Let's talk about the biological impossibilities in a deep time world. Specifically, the true titans of the fossil record the massive sauropods.
We are looking at animals like Argentinosaurus or Patagodonin. These were creatures that weighed between 70 and 100 metric tons. They stood on 4 pillar-like legs with incredibly long necks that could reach 10 meters or roughly 30 feet into the air.
I've loved dinosaurs since I was a kid, but I never once thought about the cardiovascular plumbing required to keep them alive.
Very few people do, but the physics are absolutely inescapable. We have to consider the hydrostatic pressure of the blood.
Right.
Under our current atmospheric pressure of 1 atmosphere and our current surface gravity, the mathematics of pumping dense fluid up a 10-meter vertical pipe simply to supply a brain against the pull of gravity, it just does not work.
Let's break that down for a second. To get blood to a brain 30 feet in the air, the heart has to pump with immense force.
The blood pressure required at the level of the heart to achieve that vertical lift and maintain consciousness would be staggering. Biological tissue has limits. The hydrostatic pressure required would literally rupture every known biological vessel wall.
Wait, really?
Yeah. The left ventricle of the heart would have to be so thick and massive that the heart itself would be incredibly inefficient.
So their hearts would literally explode or their blood vessels would burst just from trying to lift their heads to eat from a tree.
Essentially, yes.
If the physics are that restrictive, how do modern paleontologists explain the existence of these animals?
Well, they are forced to invent behavioral solutions to patch the biomechanical holes. Because they cannot alter the environment, uniformitarianism demands the past atmosphere was largely the same as today's. They propose that sauropods must have held their necks horizontally.
You mean sticking straight out, parallel to the ground?
Exactly. They argue these animals didn't reach up into the trees, but rather swept their necks back and forth over the ground like giant vacuum cleaners.
I'm trying to wrap my head around this. We have physical skeletons that are clearly engineered with articulated vertebrae designed for vertical reach. But because the fluid dynamics don't work in today's specific atmospheric pressure, we just assume the animal behaved in a way completely contrary to its own anatomical engineering.
That is the uniformitarian constraint actively at work. You cannot question the steady-state environment, so you have no choice but to change the animal to fit the paradigm.
It's like finding a highly advanced submarine washed up on a beach and trying to calculate how it could possibly drive on a paved highway.
That is a phenomenal analogy.
Thanks. The math won't work. The aerodynamics are wrong. The propulsion system doesn't make sense on asphalt. But instead of concluding that the vehicle was engineered for an entirely different medium like deep water, you insist it was just a very heavy, very slow car.
Right.
The math only works if you put the vehicle back into the environment it was engineered for. The author argues we're doing the exact same thing with these giant animals.
And the giant pterosaurs present the exact same aerodynamic problem. Look at the Quetzalcoatlus. This was a flying reptile with an 11-meter wingspan, literally the size of a small airplane that weighed roughly 250 kilograms.
Generating the lift to get a 250-kilogram mass off the ground is no small feat.
Under current atmospheric density, it is biologically impossible. Generating the lift required for sustained, powered flight with that mass exceeds what any known biological muscle system can output. The stall speed would be too high for the animal to safely take off or land.
So once again, the standard model must adapt the animal to protect the atmosphere.
Correct. Several prominent researchers have actually reclassified these massive pterosaurs as non-flying, ground-stalking predators. They suggest they just walked around and maybe occasionally glided from high cliffs.
So to protect the idea that the Earth's atmosphere hasn't changed, we're left with ground-grazing sauropods that couldn't lift their heads and giant winged reptiles that couldn't fly. What is water's alternative? How does he put the submarine back in the water?
Rather than changing the anatomy of the animal to fit our current world, he argues we must recognize that the world they lived in was fundamentally different. The UTGH framework posits a pre-flood Earth with a significantly denser atmosphere.
How dense are we talking?
We are talking about 1.5 to 2.0 atmospheres of surface pressure, coupled with higher oxygen partial pressure and slightly lower surface gravity.
A thicker sky. Mechanically, that solves almost everything. If the air is denser, like a fluid almost, flight becomes exponentially easier. The wings generate far more lift at lower speeds.
And if the baseline atmospheric pressure is higher, that cardiovascular pump in the sauropod's chest has a much easier time pushing blood to the brain. The denser atmosphere essentially acts as a full-body compression suit, assisting the vascular system. It's an elegant physical solution to a biological paradox.
But proposing a completely different atmosphere is a massive claim. Is there any physical evidence that this pressurized, highly oxygenated world actually existed, other than the animals themselves?
The author points to several lines of geological and chemical evidence, but one of the most compelling and one that is causing massive friction in modern paleontology is the preservation of soft tissue in dinosaur fossils.
Oh, this is where the deep timeline truly begins to fracture chemically.
Right. This is a huge point of contention.
You're referring to the T-Rex femurs and the Archaeopteryx discoveries, right?
Yes. Over the last 2 decades, researchers have recovered soft tissue, meaning flexible, unfossilized, original organic material like blood vessels, red blood cells, and osteocytes from inside the femurs of Tyrannosaurus rex specimens. Additionally, we have high-resolution, UV fluorescent outlines of soft tissue preserved in Archaeopteryx fossils pulled from the Solnhofen limestone.
And under the standard model, the T-Rex is supposed to be 66 million years old, and the Archaeopteryx is around 150 million years old.
But the laws of biochemistry set absolute hard limits on organic decay. Even if we assume the most optimal preservation conditions imaginable, let's say the animal was instantly sealed in a cold, completely anaerobic, sterile environment, the chemical bonds that hold proteins and cellular structures together break down over time.
Through entropy, essentially.
Specifically through hydrolysis and microbial activity. The absolute upper limit for recoverable original soft tissue by any demonstrated biochemical mechanism is in the range of tens to hundreds of thousands of years.
Max.
Many structural biochemists place it significantly lower.
Which means soft tissue surviving for 66 million years is not just unlikely, it's chemically impossible.
It violates the known kinetic laws of molecular decay. To preserve their timeline, the standard model is forced to ignore this biochemical limit. They propose highly speculative mechanisms like iron from the animal's blood acting as a magical tissue-fixing preservative, even though rigorous laboratory tests do not support iron preservation over millions of years.
But if we run these fossils through the UTGH framework,
Under a catastrophist timeline, the global flood event happened roughly 5,300 years ago. 5,300 years of preservation in fine-grained, rapidly deposited anaerobic sediment is well within the demonstrated biochemical preservation windows.
The chemistry requires no special pleading.
Exactly. The timeline perfectly fits the physical reality of the tissue.
This paints an incredible picture. We're looking at a pre-flood Earth that was this hyper-productive, pressurized, lower-gravity terrarium. It allowed for 100-ton animals, giant flying reptiles, and massive continent-spanning forests. So the obvious question is, what could possibly destroy it?
That is the million-dollar question.
What mechanism could completely reshape a planetary surface, bury forests under kilometers of rock, and alter the atmosphere in a matter of days? Because we aren't just talking about a really intense 40-day rainstorm here.
No, rain falling from clouds does not have the kinetic energy to bury an entire biome under kilometers of sedimentary rock. The UTGH mechanism for the global flood is fundamentally subterranean. It relies heavily on Dr. Walt Brown's hydroplate theory, proposing the catastrophic release of an enormous, highly pressurized subcrustal water reservoir.
Let's walk through the mechanics of this, because it sounds like the plot of a planetary disaster movie. How does a subcrustal ocean even work?
It's essentially a massive pressure vessel failing at a planetary scale. The text proposes that beneath the pre-flood Earth's granite crust, there was a massive interconnected layer of water. This wasn't water mixed into rock like a modern loose aquifer. It was an actual, free-flowing subterranean ocean, trapped under miles of solid rock.
So you have a sphere of water trapped inside a sphere of rock. What triggered the rock to break?
The trigger was astronomical. Specifically, the moon.
The moon.
Yeah, it was caused by tidal flexure fatigue.
Okay, I know the moon's gravity pulls on the Earth, and that's what gives us the rising and falling of the ocean tides.
That's the surface effect, but the moon's gravity also pulls on the solid rock of the Earth's crust. As the Earth rotates, the crust slightly bulges and relaxes, bulges and relaxes.
Like kneading dough.
Over centuries, this repeated cyclic stress bending the solid crust generates immense internal heat through friction. The author uses the analogy of bending a metal paperclip back and forth.
Oh, if you bend a paperclip rapidly, it gets burning hot right at the stress point before it snaps.
Exactly the same principle, but scaled up to a planetary crust. This tidal flexure heated the subterranean water layer. But because the water was trapped under miles of solid crust, it couldn't boil or expand. As the temperature rose, the pressure skyrocketed.
Building up like a pressure cooker.
The water entered a supercritical state. That is a phase of matter subjected to extreme temperature and pressure exceeding 40,000 atmospheres. The pressure kept building relentlessly until the rock crust finally suffered a catastrophic fatigue failure. A microscopic crack formed.
And from an engineering standpoint, once a crack forms in a high-pressure containment vessel,
it propagates almost instantaneously. The text suggests a global fissure propagated along what we now call the mid-ocean ridge system. It tore through the crust at velocities of kilometers per second. It literally unzipped the planet, circling the globe in a matter of hours.
So the crust rips open like the seam on a baseball. What happens to 40,000 atmospheres of supercritical water when the lid comes off?
Explosive, uncontainable decompression. The supercritical water, suddenly released, expanded massively. It tore away pulverized granite from the crust, ripped up basalt and deep mantle material, and shot upward in a continuous hypersonic jet.
Hypersonic.
We are talking about exit velocities ranging from 47 to 93 kilometers per second. This wasn't just a geyser going into the clouds. This jet had enough kinetic energy to launch millions of tons of water and rock completely out of Earth's atmosphere and into orbit.
And down on the surface, the physical landscape is being completely shredded. This isn't just water rising. The solid ground is violently breaking apart into plates.
As the mid-ocean ridges ruptured, the remaining continental land masses were suddenly severed from each other, and because they were now resting on a highly pressurized, lubricating layer of expelled subterranean water, the friction that normally holds tectonic plates in place was gone.
Oh, wow.
The text argues that the continents hydroplaned apart at catastrophic velocities. We are talking about continental drift at meters per second, not centimeters per year.
A continent moving at highway speeds. The kinetic energy involved in that is almost incomprehensible.
The Atlantic Ocean basin was literally torn open during this rupture event as the Americas sped away from Europe and Africa. And the violence didn't end there. When those massive hydroplaning continental plates finally exhausted their lubrication or encountered deep resistance, they slammed into each other.
Like a car crash.
That unimaginable, catastrophic deceleration is what buckled the crust and created the Great Mountain Ranges. The Himalayas, the Alps, the Rocky Mountains, they aren't the result of slow, invisible uplifting over eons. They are the violent crumple zones of a planetary scale car crash that occurred over a matter of days and weeks.
It's a completely different way to look at a mountain. But if the Earth physically expelled that much mass, an entire subterranean ocean, and massive chunks of its own crust shooting out into space, wouldn't that dynamically alter the physics of the planet itself? I mean, would it affect the Earth's rotation?
That is one of the most stunning cross-disciplinary connections the author makes. The physics demand a change. If a spinning object loses mass, the law of conservation of angular momentum dictates that it must spin faster to compensate and conserve its energy.
Like an ice skater pulling her arms in tight during a spin, her mass moves inward, so her rotational speed increases.
The exact same physics applies to a planet. The text calculates that the sudden, massive loss of mass from the rupture jet caused the Earth's rotation to speed up slightly.
Okay, so a faster spin.
The Earth still took the same amount of absolute time to complete its orbit around the Sun, but because it was spinning faster, it completed more full rotations during that solar orbit.
Which means the days got slightly shorter, resulting in more days in a single year.
According to this mathematical model, the pre-flood year was a perfect 360 days. The post-flood year, the one we live in now, is 365.25 days.
Wait, if the year shifted from 360 to 365 days, wouldn't ancient humans have noticed that?
They absolutely did, and they wrote it down. Look at the foundational calendars of ancient human civilizations. The Egyptian calendar, the Mayan calendar, the Babylonian, the Vedic. Every single one of these distinct, geographically separated cultures originally built their celestial timekeeping on a strict 360-day year composed of 12 30-day months.
That's incredibly specific. And what happened to those calendars?
Every single one of those cultures eventually had to amend their timekeeping systems. They had to tack on 5 intercalary days at the end of their year. And their own historical traditions don't describe this as a slow realization of a math error. They describe these specifically as the days that were added when the calendar no longer matched the sky.
That fundamentally alters how we view human history. The 5 extra days in our calendar aren't just an astronomical quirk, they are the rotational scar of the rupture event. They are a literal, historical measurement of the physical mass the Earth lost when the deep burst open.
It's an incredible synthesis. You have rigid physics mapping perfectly onto independent human historical records across the globe.
But the scars of this hypersonic jet of water and rock aren't just recorded in the math of ancient calendars. If Earth launched that much material into space at 93 kilometers per second, that material didn't just vanish into the void. It becomes planetary shrapnel. And what celestial body is sitting right in the firing line?
The moon.
Yep.
The text argues that the expelled mass from Earth bombarded the moon and other nearby celestial bodies, which solves one of planetary science's greatest, most stubborn mysteries, the extreme asymmetry of the moon.
I know the near side of the moon, the side that always faces us, has those dark, smooth patches we call the man in the moon. But I always assumed the far side was basically identical, just hidden from our view. What are we actually seeing on the back?
They look like they belong to entirely different planets. The Derail mission, which mapped the moon's gravity and crustal thickness with incredible precision, confirmed this.
What did they find?
The near side has a relatively thin crust, averaging about 60 kilometers deep. It is covered in vast, dark volcanic plains called Maria, and it is blanketed by a thick layer of fine, powdery regolith.
And the far side?
The far side has a massive 80-kilometer thick crust. It has almost no volcanic Maria whatsoever, and a completely different, heavily cratered surface texture. The standard astronomical model has struggled for decades to find a consensus explanation for why the two halves of a single small celestial body evolve so drastically differently.
So how does the UTGH framework resolve this using the rupture jet?
It relies on the geometry of the Earth-Moon system. Remember the tidal flexure that stressed Earth's crust and eventually triggered the flood? That gravitational relationship is a two-way street.
Oh, Earth was pulling back.
Earth's massive gravity was constantly pulling on the moon. Because the moon is tidally locked, meaning the same side always faces Earth, that gravitational stress was concentrated entirely on the near side. Over centuries, Earth's gravity differentially thinned the moon's near-side crust, stretching it and preloading the magma just beneath the surface.
So the near side of the moon was essentially a loaded spring, just waiting for a trigger.
Correct. Then, Earth's subterranean ocean ruptures. The hypersonic ejecta blasts into space. Because the moon is tidally locked and sitting relatively close, that shotgun blast of rocks, mud, and water hits the near side of the moon exclusively. The far side is geometrically shielded by the mass of the moon itself, so it receives zero impact from this event.
The ejecta from Earth acts as the trigger mechanism. It slams into the thin, preloaded near side.
Yes, the kinetic impact shatters the thin crust, triggering the massive, localized volcanic eruptions that flooded the basins and created the Dark Maria. And all that pulverized earthly granite and dirt settles as the fine regolith.
3 major, seemingly disconnected lunar anomalies, crustal thickness, the localized distribution of Maria, and regolith concentration are all elegantly resolved by a single catastrophic causal chain originating on Earth.
It really ties it all together neatly.
That handles the material that hit the moon. But what about the millions of tons of material that didn't reach escape velocity? What about the rock and mud that went up into a suborbital trajectory and eventually fell back to Earth?
That returning material leads to a radical reinterpretation of the most famous extinction event in geological history. We are talking about the KPG boundary and the famous Iridium anomaly.
Right, the Chicxulub asteroid. The standard consensus is that a massive asteroid hit the Yucatan Peninsula roughly 66 million years ago. It kicked up a global dust cloud, coated the Earth in a thin layer of iridium, and wiped out the dinosaurs.
The author is careful here. The text does not deny that the global iridium layer exists in the strata, nor does it deny that something massive and catastrophic impacted Chicxulub, but it fundamentally questions the origin of the impactor.
Where did it come from, if not space?
Well, iridium is a very rare element on the Earth's surface, which is exactly why scientists immediately assumed it had to come from an alien asteroid. But iridium is what geologists call a siderophile element, meaning it loves to bond with iron. It is actually highly abundant deep inside Earth's own mantle, near the core.
Oh, I see where this is going. The rupture event didn't just break the surface crust. The jet ripped up deep mantle material.
The mechanics of the rupture drove supercritical water down through kilometers of crust, physically fracturing and entraining heavy, deep mantle rock into the jet and launched it into space. The massive chunks of material that were too heavy to reach the moon eventually fell back down on ballistic trajectories weeks or months later. And because they originated from the deep Earth, they were highly enriched with Earth's own iridium.
So the Chicxulub asteroid wasn't an asteroid at all. It was a massive, dense chunk of Earth's own expelled mantle falling back down on itself like a ballistic missile.
According to this framework, the KPG iridium anomaly is not the signature of an alien rock. It is the final settling deposit of Earth's own returning ejecta, blanketing the planet in the final stages of the flood year.
If we accept this premise, we are looking at the solar system not as a series of isolated billions of years old puzzles, but as a single incredibly fresh crime scene. The water discovered on Mars, the icy rings of Saturn, the asymmetrical craters on the moon. Wait, no ellipses. I mean the icy rings of Saturn, the asymmetrical craters on the moon. It's all essentially planetary shrapnel from Earth exploding just 5,300 years ago.
That is the grand unifying hypothesis. But as any student of geology knows, there is a massive, seemingly insurmountable roadblock for this 5,300-year timeline. If all this catastrophic reshaping happened so recently, what do we do with radiometric dating?
This is the elephant in the room. Geologists take pieces of rock into pristine laboratories. They run them through incredibly expensive mass spectrometers, and the machines say the rocks are tens or hundreds of millions of years old. You can't just ignore physics and chemistry.
The author is meticulous in his approach here. He emphasizes that he does not claim radiometric physics is bad science. Radioactive decay is a real measurable phenomenon. Uranium turning into lead or potassium turning into argon at a steady, measurable rate is a fact of physics. The laboratories are staffed by brilliant, honest scientists using instruments that measure isotopes with astonishing precision.
So if the machines work perfectly, the physics of decay are real, and the scientists are honest, how can the resulting dates be wrong by hundreds of millions of years?
Because there is a fundamental difference between precision and accuracy. It's not the physics of the mass spectrometer that are wrong, it is the philosophical assumptions underpinning the equation.
The assumptions.
Radiometric dating methods, whether it's uranium lead, potassium argon, or rubidium strontium, all rely on 3 unprovable assumptions to calculate an age. First, you must assume you know the exact initial conditions of the rock when it formed.
Okay.
Second, you must assume the rock has been a perfectly closed system for its entire existence, with no contamination entering or leaving. And third, you must assume the decay rate has always been constant.
And the text argues that the rupture event completely shatters those first two assumptions.
Completely. These dating methods mathematically assume a world in steady-state chemical equilibrium. They assume a rock cools slowly and sits undisturbed. But the rupture event was the ultimate chaotic planetary-scale mixing event.
Everything got scrambled.
It violently combines subcrustal water, surface rock, seawater, and deep mantle material, which is rich in radioactive isotopes at supercritical temperatures and pressures.
It's like trying to date when a cake was baked, by carefully measuring the amount of flour left in it. But you don't realize someone threw the finished cake into an industrial blender with raw dough, poured radioactive waste on it, and set it on fire. Your measurements of the flour are perfectly precise, but your calculation of the bake time is completely meaningless.
Let's look at the physical proof of this. The text points to the Mount St. Helens control case as the smoking gun for how initial conditions can be corrupted. In 1986, a new dacite lava dome formed inside the Mount St. Helens crater. Geologists knew for an absolute fact that the rock was less than a year old when it was physically sampled.
Because they watched it cool and harden?
Exactly. They sent this known one-year-old rock to a highly respected standard geochronology lab and asked them to date it using the potassium-argon method. The results came back stating the rock was up to 2.8 million years old.
A rock that we know is 1 year old dated at nearly 3 million years old. How does that chemistry fail that badly?
Because of a phenomenon called inherited excess argon. Down in the magma chamber, before the eruption, the magma absorbed argon gas, the daughter isotope, under immense pressure.
Oh, I see.
The initial condition assumption of the dating method that a new rock starts with 0 daughter isotopes was entirely wrong. The clock was preloaded. It looked millions of years old the very second it cooled.
And if a tiny, highly localized eruption like Mount St. Helens can preload a chemical clock with millions of years of air, imagine what a planetary rupture event involving supercritical water and deep mantle mixing would do.
The author argues that the floodwaters essentially reset all the geological clocks on Earth with severely corrupted initial conditions. Every volcanic rock formed during or immediately after the event inherited a massive, chaotic dose of radiogenic isotopes from the deep Earth. The clocks are ticking accurately today, but they were set to the wrong time when they started.
But wait, I've read that scientists don't just rely on one test. They will use multiple different dating methods on the exact same rock. They might use uranium-lead and then use rubidium-strontium, and both methods will converge on the exact same deep time date.
Yes, that is common.
If the dates were just random errors caused by mixing, they wouldn't match. Doesn't that convergence prove the deep time date is accurate?
That is the strongest argument for deep time, and the text addresses it through a statistical concept called correlated error. If two different people look at their watches and both say it's 3:00 p.m., you assume it's 3:00 p.m. That's independent confirmation.
Makes sense.
But what if both watches are broken in the exact same way?
You're saying that dating methods aren't truly independent?
Analytically, they are measuring different elements. But epistemically, they are not independent because they both share the exact same failure mode. Both chemical systems within that rock were subjected to the exact same chaotic, catastrophic hydrothermal mixing event at the exact same moment.
They were corrupted together.
Right. If the supercritical floodwaters injected a specific skewed ratio of heavy isotopes into the entire rock matrix simultaneously, then every single radiometric method used to date that rock will yield the same mathematically precise yet fundamentally incorrect date.
The convergence doesn't prove the age is right. It just proves that both elemental clocks were broken by the exact same hydrothermal event. They are incredibly precise measurements of the wrong initial conditions.
Precisely. Radiometric dating was designed to date rocks formed under conditions of chemical equilibrium. The rupture event produced a world of rocks born in chemical chaos.
Okay, if we mathematically strip away the deep timeline, if we accept that the rocks are only thousands of years old, suddenly we are looking at Earth's recent history completely differently. The bizarre anomalies of the Ice Age, the sudden extinction of the megafauna, they aren't random, isolated events separated by eons. They start to look like the immediate, brutal aftermath of this global catastrophe.
Under the Standard Model, scientists must invent dozens of distinct ice ages advancing and retreating over millions of years, driven by incredibly subtle, almost unnoticeable changes in Earth's orbit. And that model famously struggles to explain the sudden catastrophic extinction of millions of woolly mammoths at the end of the last freeze.
The text focuses heavily on the Berezko mammoth to highlight this failure, doesn't it?
It does. The Berezovka specimen is a critical anomaly. It was found flash-frozen in the Siberian permafrost. It wasn't just buried. The meat was still remarkably fresh. And most importantly, in its mouth and inside its stomach were unswallowed, perfectly preserved summer buttercups and temperate grasses.
The paradox here is temperature. You need a warm, temperate summer climate for the buttercups to grow and for the mammoth to be casually grazing. But you need an instantaneous, catastrophic deep freeze to preserve a massive, hairy, blubber-insulated animal before the meat rots or the stomach acid can digest the delicate flowers.
A gradual climate change, creeping in over hundreds or thousands of years, as the standard orbital theory suggests, does not flash freeze a mammoth mid-bite.
No, it definitely doesn't.
A slow freeze would allow the animal to digest its food, rot, or migrate. To freeze a mammoth core solid before putrefaction sets in, engineers have calculated you need to drop the ambient temperature to around minus 150 degrees Fahrenheit almost instantly.
How does the UTGH framework create a minus 150-degree flash freeze on a summer day?
Through a well-understood physical process called adiabatic cooling. We have to go back to the hypersonic expulsion of Earth's mass. When the ruptured jet launched millions of tons of water and rock into space at 93 kilometers per second, it literally blasted a hole in Earth's atmosphere.
It pushed the air out of the way.
It created a massive, temporary partial vacuum in the atmospheric column. Nature abhors a vacuum. To fill that sudden void, the extremely thin, supercooled air from the mesosphere, which sits dozens of miles up at roughly minus 90 degrees Celsius, crashed downward to the Earth's surface at catastrophic hurricane speeds.
It's like popping the seal on a vacuum chamber, but the chamber is the sky.
And here is where the physics of adiabatic cooling take over. As that supercold air descends violently, it expands into the lower pressure zones left by the jet. When a gas expands rapidly, its temperature drops even further. Think of how the compressed air from a computer duster can gets freezing cold when you spray it.
Oh, that makes total sense.
This descending, expanding column of ultra-cold air hit the surface, instantly flash freezing what the author calls population 1 of the pre-flood fauna. The mammoths literally froze to death in the middle of a summer day, entombed in ice that would eventually become the permafrost.
That paints an apocalyptic picture. The Earth is cracking open, boiling water is shooting into space, continents are hydroplaning, and the sky is raining supercooled death. If the world froze, flooded, and shattered simultaneously, how did humanity survive? The text clearly treats the biblical Noah account as a literal historical log, not a moral myth. It says only 8 human beings survived on a specially engineered vessel.
This is where the author pivots from physical geology to biological and genetic arguments. Standard population genetics argues that a severe bottleneck of only 8 people would result in catastrophic inbreeding depression. A population that's small, lacks sufficient genetic diversity to survive, they would go extinct from accumulated genetic defects within a few generations.
But the text argues that we are making a fatal error by applying modern, heavily degraded biological metrics to ancient, pristine biology.
That's the key. The author posits a front-loaded genetic bottleneck. He suggests that the original pre-flood human genome was incredibly rich. It contained the maximum possible informational fidelity and had almost zero accumulated mutational load, no inherited genetic diseases.
Why was their DNA so pristine compared to ours?
Because of the pre-flood environment we discussed earlier. The denser sky, 1.5 to 2.0 atmospheres, combined with a potential vapor canopy, would exponentially attenuate incoming ultraviolet radiation and cosmic rays.
UV radiation is a primary driver of cellular aging and DNA damage.
Right. Without that continuous lifetime bombardment of radiation, the biological clock ran entirely differently. Germline mutations didn't constantly accumulate generation after generation. The genome remained clean. So when those 8 survivors stepped off the ark, their genetic code was robust enough to handle the severe population bottleneck without suffering from inbreeding depression.
But standard biology says you need tens of thousands of years of random mutation to generate the incredible racial and physical diversity of the human race from a small starting point.
The UTGH framework argues that diversity doesn't require random mutation over deep time. It requires rapid epigenetic expression.
Epigenetic expression.
The pre-flood genome was front-loaded with immense adaptive potential. When those survivors spread out from the landing site into the harsh, UV-drenched, chaotic, completely unpredictable post-flood world, the extreme environmental stress triggered rapid epigenetic shifts.
This is a reaction to the environment.
Yes. The biological diversity we see today wasn't built slowly by accidental mutation. It was rapidly expressed from existing built-in genetic potential to ensure survival in varied climates.
It's like having a Swiss Army knife. The tools are already there, built into the device.
Yeah.
You don't wait a million years to evolve a screwdriver. You just deploy the specific tool you need based on the environment you suddenly find yourself in. And there's a measurable decay curve to this biological transition recorded in history, isn't there?
Yes, and it's fascinating. The text points to the genealogical records preserved in Genesis. If you graph the lifespans recorded there, they drop dramatically and mathematically in the generations immediately following the flood. Noah supposedly lived 950 years. A few generations later, Peleg lived 239 years. A few generations after that, Joseph lived to 110.
It forms a perfect biological decay curve. It's graphing a highly resilient, pristine biological system rapidly adjusting to the sudden loss of a protective, pressurized atmosphere and the influx of radiation. It's not symbolic numbering, it reads like a physiological log.
And it isn't just the physical changes to the body that are logged, it's the memory of the catastrophic event itself. Over 270 distinct geographically isolated cultures globally, from the Andaman Islanders in the Indian Ocean to the indigenous tribes of the Americas to the Sumerians, the Greeks, and the Aboriginal Australians, all share a foundational Great Flood memory.
They all remember the exact same beats. A world-ending inundation of water, a tiny handful of survivors saved on a boat, and a completely changed, harsher world afterward. It's as if humanity woke up with collective amnesia, living in the shattered ruins of a highly advanced, massive biological terrarium. And we've spent the last few centuries trying to piece the story together using a completely incorrect timeline.
Standard anthropology tries to explain this away by saying these are just shared myths borrowed through ancient trade routes, or exaggerated memories of local river floods. But the author argues that cultures like the Andaman Islanders were completely isolated for millennia. They didn't trade stories. They share the story because their ancestors survived the exact same physical planetary event. The global human memory is the final corroboration of the geological rocks.
Okay, let's pull all these massive threads together. This has been an absolutely staggering deep dive. We've looked at knife-edge rock layers that show no time passing, polystrate trees standing through millions of years of sediment, the biomechanics of 100-ton sauropods that require a thicker sky, a hypersonic jet of subcrustal water ripping continents apart, the resulting scars on the near side of the moon, the flash-frozen mammoths in Siberia, and a human genetic bottleneck that rapidly adapted to a broken world.
It is a comprehensive, holistic reevaluation of the earth sciences. Whether you ultimately accept the Standard Model's deep time narrative or you find yourself compelled by Water's unified theory of geologic history, the intellectual exercise of questioning the foundational assumptions of uniformitarianism is vital for science.
It really is.
The author asks us to follow the physical anomalies, the fresh dinosaur tissue, the impossible physics of giants, the correlated error in dating methods rather than inventing eons of unseen time and special localized rules just to brush the uncomfortable data under the rug. Science requires us to relentlessly interrogate the evidence, not protect a legacy paradigm.
And what makes this text so compelling is that the author isn't just throwing out wild theories about the past. He's making testable, falsifiable predictions about the present, which leaves us with a final, incredibly provocative thought. Let's talk about the samples in the drawers.
This is the ultimate challenge the text lays down. The author points out that we already have the physical material needed to empirically test his catastrophist model today. We don't need a time machine.
We can test it right now.
Exactly. For example, core samples from the oldest living giant sequoia trees that theoretically date back to the immediate post-flood boundary are currently sitting in university archives. They could be tested right now for the specific isotopic and iridium signatures that this global ejecta model predicts would be present in the atmosphere during their initial growth rings.
And there are deep-sea drilling cores taken from the mid-ocean ridges. Those could be microscopically examined today to see if the fracture patterns in the basalt show the signatures of rapid, brittle, high-pressure failure caused by escaping supercritical water, rather than the slow, ductile spreading required by standard plate tectonics. The exact tests are defined in the text. The physical samples are literally sitting in institutional drawers gathering dust.
The only thing stopping the scientific community from running these exact falsifiable tests is the lack of a theoretical framework that suggests they're worth doing. Or, perhaps more cynically, it is the institutional fear of what they might find if the uniformitarian clock is definitively proven wrong.
It really makes you wonder, what else is sitting in our scientific archives perfectly preserved, just waiting for a new paradigm to finally read it correctly? Are we staring at the shattered glass of our planet's history and still desperately trying to prove that a bird dropped the baseball? Thank you for joining us on this deep dive into Earth, a biography of chaos. Keep your eyes open, never be afraid to question the academic consensus, and never stop looking closely at the rocks beneath your feet.